1. Oh, yeah, that's appropriate that I'm counting down because we're doing counting today. So counting actually relates to probability, and eventually probability relates to statistics. So we're going to start with 3 counting principles today. And the first one is called the multiplicative principle, and we're going to look at tree diagrams. So here I have a coin. It's a completely fair coin. I've got heads or tails, and I have a gaming cube. Okay, and once again, a completely fair gaming cube. And so here we go. Here's the game. Toss the coin, and you can get heads or tails, and then throw the gaming cube, and you can get anywhere from 1 to 6 on this completely fair gaming cube. So, how many outcomes are there? Duck or Mexican cat or duck? How many possible outcomes are there?
12.
12.
Yeah, that's right.
And that's the multiplicative principle, okay? So, multiplicative principle. Okay, if you can divide a process up into a certain number of stages, you just find the total number of possible outcomes by multiplying the number of possible outcomes at each stage, okay? So in multi-stage processes, find the total number of outcomes by multiplying the possible outcomes at each stage. And I don't think this is terribly puzzling or alarming to anybody. Stage 1, you're tossing a head or a tail. 2 possible outcomes that can be linked up with stage 2, which is anywhere from 1 to 6. Now, the curriculum says that we need to understand how this can be done using a tree diagram. And so we're going to go over a tree diagram, what it looks like. So there's stage 1. You can get a head or a tail. And here comes stage 2. This is going to take a lot more room. 1, 2, 3, 4, 5, 6. So you can get 1, 2, 3, 4, 5, or 6 at stage 2. And so here are all your outcomes. You can get a head and a 1, a head and a 2, head and a 3, head and a 4, head and a 5, head and a 6. And then we can do the tails the exact same way. And this is going to complete our tree diagram. And you can see how the multiplicative principle looks from this tree diagram. 1, 2, 3, 4, 5, 6. Okay, so that's the multiplicative principle. Just count the number of outcomes at each stage, multiply them together. That's the total number of outcomes. Notice that the outcome on stage 1 in this case does not have any impact on the outcome in stage 2. And we're going to look at processes where, you know, we say pull a ball out of a bag and don't replace it, in which case the first outcome is going to influence the number of possible outcomes in the second case, but this is just simple counting. Okay, so there's the multiplicative principle. Now we're going on to indirect counting, which is seems simple, is really pretty useful, and is really useful when you get into trying to find the number of outcomes when some of them are difficult to calculate. Okay, so if we threw 2 dice, now there are a couple of ways in the example I'm about to give of doing this, but if we throw 2 dice, In my favorite game, Monopoly, everybody likes to get double sixes. So this is a nice matrix that you can use to keep track of probabilities for throwing 2 dice. Okay. So total number of outcomes is 36. Number of outcomes that involve a 6. Sorry. Number of outcomes that involve 2 6s. So how many outcomes involve throwing 2 6s out of the 36? Duck. 2 6s. So how many outcomes involve throwing 2 6s?
1.
That's right. Yeah, there's only one that involves throwing 2 6s. Okay. Now, if this was even more complicated, this is maybe too simple an example. We want to know the number of outcomes that don't involve 2 6s. Okay, so I could do this 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there an easier way? How many outcomes don't involve 2 6s?
35.
35. Yes, that's right. So 35 outcomes. I'm guessing that you probably calculated that by taking 36 and subtracting 1 rather than counting all 35 possible other outcomes. Now, in this case, that was a simple example. We're going to look at some examples a little bit later on where it's really hard to figure out how many outcomes of interest there are, but it's fairly easy to figure out how many outcomes we're not interested in. And so we would just take the total and subtract away the ones we're not interested in. So that's this nice indirect method of counting. Okay. Finally, we're going to look at the additive principle. The additive principle is the one that we use when the outcomes involve mutually exclusive events. And so if one set of things can happen, another set of things can happen, but you can't have both things happen at the same time. And so if one happens, you know the other isn't happening. Okay, so this is for outcomes that involve exclusive events. In other words, when one event happens, it excludes the other one. So here comes the example. You can throw a coin, or you can toss a dice. I mean gaming cube. Okay, I mean dice. Okay. No, and I mean die as well because it's singular. What's the plural of mice? Is it my? I don't think so. So singular of dice would be die. Okay, so you can throw a coin or you can toss a gaming cube. Okay, so if I throw the coin, that's it. I'm not allowed to toss the gaming cube, so it's kind of like you can pick what's in the envelope or you can pick what's behind door number 1, 2, or 3. Okay, Mexican cat, you've been noticeably quiet. How many possible outcomes are there to this fun game? How many possible outcomes are there to this fun game?
Two.
2 is absolutely wrong. 2 possible outcomes.
Throw the coin. 12.
That's right. You can throw the coin or you can toss the dice.
8.
8 possible outcomes. Yes, there we go. So you could get heads, tails, 1, 2, 3, 4, 5, or 6. Okay, but you can't get like a 1 and a head. So there's 1, 2, 3, 4, 8. There are 8 possible outcomes. So these are exclusive of one another. We use the additive principle here, and that's it. That's all we're doing for today as far as counting goes.